In today's walkthrough, we'll be looking at problem 1 on the week 2 worksheet. So we're given an undirected graph, and there's 6 vertices on this graph, namely A, B, C, D, E, and F. So our answer to part A is 6. Part B asks us, what is the degree of vertex B? So vertex B is adjacent to 1, 2, and 3 other vertices. So the degree of vertex B is 3. What's the total degree of this graph? The total degree is the sum of each of the degrees of each vertex. So vertices B, A, E, and D all have degree 3. And vertices F and C both have degree 2. So our total degree is 3 times 4 plus 2 times 2, which is equal to 16. Now we're asked to consider the traversal A to B to C to D to A. And we're asked to categorize it as either a walk, cycle, simple path, or tour. So let's start with a walk. Is this a walk? Yes, because in a walk we're allowed to repeat edges and vertices. What about a cycle? In a cycle, we're not allowed to repeat edges, and the only vertex we're allowed to repeat is the start vertex. And we started at A and ended at A. So it is indeed a cycle. What about a simple path? Well, this would not be a simple path because we can't repeat vertices. What about a tour? What is a tour? Because we start and end at the same vertex. Okay. Part E asks us to give an example of a simple path of length 4. So let's remember what a simple path is. It's just any path from one node, say point A, to another, say point E, where we don't repeat any edges or vertices along that path. Okay. So what's an example of a simple path of length 4? Well, we can go from A to B, then to C, then to D, and then to E, right? And on this path, we don't repeat any edges or vertices. So that's one example. Actually, that's a path of length 5. So if we can remove E. There are many examples of such paths. For example, you could have said A to F to E to D. Anything would work. Any simple path of length 4 would work. Okay. Part F asks us, is it possible to construct a traversal that is an Eulerian tour, but not a simple cycle? Why or why not? So let's first recall what an Eulerian tour is. So an Eulerian tour is, a tour on the graph where we visit every edge exactly once. And what are the conditions for an Eulerian tour, right? Let's write those out. So an Eulerian tour exists if and only if our graph is 1, connected, and 2, even degree, meaning every vertex in our graph has even degree. Now remember, we said that vertex B has degree 3, hence our graph is not even degree, and hence it does not have an Eulerian tour. So our answer is no. this is not possible since our graph is not even degree, meaning it doesn't have an Eulerian tour. Okay, part G. In terms of the number of edges and the number of vertices in our graph, what's the sum of the degrees in our graph? So remember, each edge, so for example, if this is an edge, each edge in our graph adds 1 degree to each vertex that it connects. And it connects 2 vertices. For example, this edge connects vertices E and D, and it contributes 1 degree to vertices E and D. So we can then claim that the sum of the degrees of our graph is equal to 2 times the number of edges. Now part H asks us, what is the average degree of the graph? Now in part G, we calculated the total degree of our graph, which was 2 times the number of edges. So to get the average degree of our graph, we can just do 2 times the number of edges divided by the number of vertices. So one way you can interpret the average degree of the graph is it's the average degree of any vertex in the graph. Thanks for watching.